Hi everybody, here's your video for the 10.4 notes. Remember to have your 10.4 notes right there by your side, your computer or however you're watching this, so you can write the notes down and fill in all the information that is missing on those notes. So in section 10.1, you learned about circles and then how to determine if a line is tangent to a circle. And we did a lot of work on tangents and radii and things. In section 2.2, you learned the vocabulary of arcs, major arcs, minor arcs, semicircles, and how to determine if an arc is major and minor, how to write their labels, and what makes them congruent. Okay, in the last section, you learned about chords and how to use them to find the measure of an arc. And we had 4 theorems about chords. In this section, you're going to learn about inscribed angles and intercepted arcs. And then there are also going to be 2 theorems that, actually take that back, there's 3 theorems that you'll need to know. Okay? So, okay, first of all, vocabulary. Okay, an inscribed angle. Okay, here's an inscribed angle. Is an angle whose vertex is on a circle. There's the vertex right there. Okay, and it's on that circle. And whose sides contain chords of the circle. Okay. So here's the side. Okay, and it's a chord because it ends at the circle, at the boundaries of the circle. And then here's another chord. Okay, and they end at the boundaries of the circle. Okay, so just for interest, inscribe is from the Latin word inscribere. Okay, and that's where the Spanish inscribir comes from. And literally it means to write inside. So the angle is written inside the circle. So that's one way that you can remember it. Okay. Okay, an intercepted arc, okay, here's intercepted arc, lies in the interior of an inscribed angle. Okay, so here's my inscribed angle. Okay, an intercepted arc line is in the interior of that angle and has endpoints on the angle. Okay, so there's one endpoint right there, and here's one endpoint right there. Okay, and this comes from the word intercept. So intercept is from the Latin intercepere. It's where the Spanish interceptar comes from. And literally it means to stop or interrupt. So the lines of the angle intercept the circle. Okay, so the lines of the angle come out and they actually stop the circle, or they interrupt the circle. And that's why it's called an intercepted arc. Okay, so those are our 2 vocabulary words for this section. And then I want you to notice a few things about these inscribed angles. So all 3 circles have an inscribed angle inside of them. Notice that its vertex is on the edge and its sides are chords. Okay. Now this one, the one on the left, this chord actually happens to be the diameter. And remember how we talked yesterday about how a diameter actually is a chord. Okay, it's a line that is inside the circle and it ends on the sides of the circle. Okay, the diameter happens to run through the center of the circle, and that's what makes it the diameter. Okay, so in this circle, here's our inscribed angle. And here, you have one side on one side of the center, and you have one side on the other. And that's completely fine, okay? It's still an inscribed angle. And finally, in the third one, here you have an inscribed angle where both sides happen to be on one side of the center. and that's okay too. So your inscribed angles can look like any of these three. And you'll find as we go through the problems that probably the trickiest part of this whole business with inscribed angles is figuring out exactly what angles you're talking about. Okay, because once you put in several inscribed angles into a circle, it can start looking really complicated. Okay, so here's our first theorem for this section. And this theorem tells us the measure of an inscribed angle. Now you can imagine how handy that is going to be. Can you see all those quiz and test questions asking you to find the measure of an inscribed angle? Okay, so this theorem is super important. So the theorem says the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So what does that mean? That means if you have an intercepted arc of a certain measure, then this angle is going to be 1/2 of that measure. Okay, so let's look at some examples down here. Here's our three types of inscribed angles. So say, for example, my inscribed arc is, looks like, let's try 40 degrees. So if we know that 40 degrees, we know then that this angle has to be 20 degrees. Okay. If the second circle, see, what could this be? Maybe 86 degrees, maybe? So we're going to make that arc is like 86 degrees. Okay, so this angle would be, would be 43 degrees. Okay, now what if you were given the opposite information? So you were given this angle. So say this angle is 12 degrees. So what would this inscribed arc be? It would be 2 times 12 equals 24 degrees. Okay, it's very simple. The way I remember it too is that the inscribed arc is always bigger than that angle. So you can remember that the inscribed arc is twice the smaller angle. Okay, that's kind of how you remember which one is multiplied by 2. Okay, so let's look at, let's practice using it. Okay, so again, we're using the theorem that says the measure of an inscribed angle is half the measure of its arc. So in this first one, it's asking for the measure of angle T. Okay, and the measure of its inscribed angle is 48. And remember, the T is going to be smaller, so the measure of angle T is going to be 1/2 the measure of arc RS is going to equal 1/2 times 48 degrees, and that's going to equal 24 degrees. Okay, easy peasy. So let's look at, I'm going to change colors. Okay, now you're being asked for this. Okay, now there's no inscribed angle, okay, that uses QR as its endpoints. Okay, if we had an inscribed angle for QR, it would look something like this. Okay, but this line here doesn't exist, and this line does exist, but it doesn't do us any good. Okay, all by itself. So what do? Now, this is something that I noticed some of you were kind of struggling with in the last homework, and that is noticing what this line TR is. Okay, and what is TR? Sorry, shuffling papers here to remember to tell you everything. So, first of all, line TR is a diameter. Okay, it is a chord that touches both sides of the circle and it runs through the center. So it is a diameter. Okay, so what is the measure of the arc TR? TR is going to... Okay, and we know that since the TR is a diameter, it cuts the circle in half. And the whole circle is, the measure of the whole circle is 360 degrees, so the measure of half the circle is 180 degrees. So the measure of arc TR is 180 degrees. Okay? So, let's start taking that apart. So, we also have this convenient 50 degree here. Okay, so we know that this arc here, so the measure of arc QT is equal to 2 times its inscribed angle, 2 times 50 equals 100 degrees. So we know that this part right here is 100 degrees. We know the whole thing, the whole arc TR is equal to 180 degrees, so what do? Okay, we take 180 degrees, we subtract 100 degrees, that leaves us with 80 degrees. So this arc right here has to be equal to 80 degrees. Okay, so that took a couple steps. Okay, and you had to realize that line TR was a diameter. And so that arc of TR had to be equal to 180. Then you had to notice that you know what the measure is of this arc because you were given the measure of its inscribed angle. Okay, and then you have to do a bit of subtraction to get it done. But this is very typical of problems that you'll see in the homework and on quizzes and tests. So here is our second theorem. So the second theorem says if 2 inscribed angles of a circle intercept the same, emphasis on same arc, then the angles are congruent. Okay, so let's look here. So we have an inscribed arc here. Okay, then I'm going to change colors. And we have an inscribed arc here. Okay, they are both ending up at the same point on the circle. Okay, so by this theorem, theorem 10.8, we know that not only are these arcs the same, AB is the same for both of these inscribed angles, but it means that their angles are the same. That will also come in very handy. So let's look at this example down here. Name 2 pairs of inscribed angles and tell whether or not they are congruent. So this is where you can get a little trapped, okay, if you're not used to looking at inscribed angles. So let's look for our first pair. So my eyes see this inscribed angle. Okay, and so that would be angle WXZ. Okay, and the other inscribed angle that ends up at the same points is WYZ. Okay, perfectly good. Okay, now, okay, let's erase these guys. And we'll use a different color. There's another way to look at this. Okay, here is another inscribed angle. And here is another inscribed angle. Okay, and they're both meeting at these 2 points. So we have angle XWY and angle, let's see, XWY and angle XZY. Okay, so those are two pairs of inscribed angles. Next question is, are they congruent? Well, let's see. So let's take this second pair since I've erased the blue. So XWY, and XZY. Okay, so it's asking if these two angles are congruent. So let's look at our theorem. If two inscribed angles of a circle intercept the same arc, okay, they are intercepting this arc. Okay, here they are. That's where they intercept. They intercept the same arc. So then the angles are congruent. And sure enough, we can say XWY, okay, and XZY are congruent. Okay, so let's look at, oops, first we need to erase. This is fun. Okay, let's go back to blue. So WXZ, okay, WYZ, okay, and they intercept the arc, the circle at the same spot. Okay, so this is their arc. So if two inscribed angles of a circle intercept the same arc, which they do, then the angles are congruent. So WXZ is congruent to WYZ. And we can fix this and say the two are congruent. Okay, so these are both going to come, both these theorems are going to come in super handy in your homework. So make sure that you understand them. Okay, so let's do a little bit more practice with these. Okay, so first we want to get the measure of arc RS. So where is that? That is right here. Okay, so that's the arc, the inscribed arc. This is the angle, its angle, and lo and behold, its angle is 31 degrees. So we know by the previous theorem that the measure of arc AS is going to be equal to 2 times the measure of its angle, which is SUR, equals 2 times 31 equals 62 degrees. And I'm done. Okay, so let me change colors. And I'm going to erase this. Okay, so now we're looking for the measure of angle STR. Okay, now we have the inscribed angle STR. Okay, we also have the inscribed angle RUS. Okay, so STR and SUR both, this is the arc for both those inscribed angles. Okay, so since they share the same arc, their angles are the same measure, and that becomes angle T, or you could say angle STR is equal to 31 degrees because they share that same angle. So what do you notice about angle STR and angle RUS? And obviously they are congruent. Okay, so one thing you want to make sure here is that you didn't mix up. I'm going to put in red because that's not what you should do. Okay, you didn't try to use these angles. Okay, because while they are two inscribed angles that share an arc, okay, so we know that this angle is equal to this angle. That's all well and good, but you don't know what either of them are. So it's not going to help you. So what you had to do is look at these angles, okay? One of which was given to you, okay? And so that's what made the problem doable. If you had tried to do it with the red angles, you would not have been able to do the problem, okay? One more theorem. Okay, I'll leave it at green. So this one is really kind of interesting if you think about it. So it states that a quadrilateral, and this can be any quadrilateral, okay? Any quadrilateral can be inscribed in a circle if, and only if, its opposite angles are supplementary. Okay, what does supplementary mean? It means if I add them together, they equal 180 degrees. Okay, so, and if you could somehow put a quadrilateral in a circle that didn't have, well, if you tried to put a quadrilateral that didn't have the opposite angles supplementary, it would not fit in a circle. It might be kind of fun to try that sometime, but it just means that any quadrilateral can be inscribed in the circle, but only if its opposite angles are supplementary. So F and D have to add together to equal 80 degrees, and E and G have to add together to get 180 degrees. Okay, now you can imagine this turns out to be very handy. So let's look at number 5 below, and they want you to find X and Y. So we're going to look at, okay, the first one, 68 degrees plus Y degrees is going to equal 180 degrees. Okay. Subtract 68 from both sides, and Y becomes, sorry, I had this written down so I didn't have to do it on the fly. Y is equal to 112 degrees. Okay, so let's look at X. So 82 degrees plus X degrees is going to equal 180 degrees. Okay, X degrees is going to equal to 180 minus 82 is equal to 98 degrees. Okay, so just remember, anytime you see a quadrilateral, okay, a shape with 4 sides inscribed into a circle, okay, you know that those opposite angles are going to be supplementary. They are not equal like on a rhombus. Okay, don't get those confused. Okay, a rhombus is not inside a circle. Okay, they only are supplementary if they are inside a circle. Okay, let's look at number 6. So here we have, let's take S and U. Okay, so C degrees plus 2C minus 6 degrees is going to be equal to 180 degrees. Okay, so that C degrees plus 2C degrees is going to equal 3C degrees. Okay, then I'm going to add the 6 to both sides, equals 186. so C has to be equal to 62 degrees. Now let's look at these two. So 10x plus 8x is going to equal to 180 degrees. 18x equals 180 degrees. X equals 10 degrees. We divided both sides by 18. Okay, so here we have our x and our c. And here over on the left side we have our x and our y. Okay, so again, it's it's important to remember that we have a quadrilateral inscribed in a circle. Inscribed means it's written inside. Okay, from the Latin. And remember, excuse my scratchy drawings, but this could be any quadrilateral. Okay, this angle, these two angles would be supplementary, and these two angles would be supplementary. So no matter how goofy they look, if it's a quadrilateral and it is written inside the circle, is inscribed in the circle, then its opposite angles are 180 degrees, are supplementary. Okay, one more here. We're going to practice using our theorems a little bit. So you want to find the measure of the red arc or angle. Okay, on your paper, obviously these aren't red, so you might want to mark them in some other way on your notes. Okay, you either get a red pencil or just a different color or something. Okay, so we need to find the measure of the red arc or angle. So that must be in number 1, that must be that angle right there. Okay, here we have our two theorems. Okay, this has nothing to do with quadrilaterals. None of these three do, so you're not going to use that last theorem. So the only candidates are the first two theorems. Let's look at the first one. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. Okay, so I think that would be really handy here. Here's the intercepted arc. Okay, it's 90 degrees. So the measure of angle HGF has got to be 1/2 times 90 degrees equals 45 degrees. Okay, so we use theorem number 10.7. So let's look at number 2. Okay, we need to find the measure of this angle, or that arc, TV. Okay, again, if we look at 10.8, it says of two inscribed angles of a circle. We don't have two inscribed angles, we've only got one. So that means that theorem 10.7 is the only one that we can use. And again, the measure of the inscribed angle is 1/2 of its arc. So the measure of our arc TV is going to be equal to 1/2 the measure of angle TUV is equal to 1/2 times 38 is equal to 16, right? Yeah, 16, yeah. Nope, 18. Sorry. No, 19. Good grief. It's late. Sorry. There you go. It is 19 degrees. Okay, so now we've used theorem 10.7 twice. Now let's look at number 3. Okay. Now here we have two inscribed angles. So theorem 10.7 isn't going to help us, but theorem 10.8 is. Okay. So what are our two inscribed angles? So remember, we're going to be smart about which ones we pick. So we want to find out this red one here. Okay, and conveniently, the one that shares its arc, okay, is the one that's given. Yay! So if two inscribed angles intercept the same arc, they share the arc, then the angles are congruent. Yay! So we know the measure of angle X, okay, is congruent to the measure of angle Y, and therefore the measure of angle X has to equal 72 degrees. Okay? So, just for argument's sake, I'll erase first, just so you can make sure you're seeing the right stuff. Okay, let's look at what would not be the way to do this. Now you have an inscribed angle here, and you have an inscribed angle here. They share the same arc. Okay, all's well and good, but you have no clue what these guys are. Okay, so those two inscribed angles do you absolutely no good. Okay, so that's why. Okay, well, it helps they gave you the red one, right? But that's why you're going to use these two. Okay, so that's really all there is to this section. Okay, so good luck with the homework. Remember to ask any questions that you need to.